Good morning, students. Compressibility factor for real gases can be written as Z is equal to PV real divided by N naught T. Equation number 1. V ideal equal to, that means volume ideal equal to N naught T divided by P. Equation number 2. Equation number 2, substituting equation number 2 in 1. 2 in 1 means that PRT equal to Z is equal to V real divided by V ideal. That is equation number 3. Equation number 3, where V real gas, molar volume of real gas and molar volume of ideal gas behaves in ideal only. Behaves ideal only. Next, van der Waals equation. Van der Waals equation from J.D. van der Waals only discovered. Analysis of real gas only. Analysis of real gas. Analysis of real gas molecular level ideal gas equation. Ideal gas equation. What ideal gas equation? Got it? PV is equal to N naught T. This is for ideal gas equation. That equation correction for two. First one is the pressure. Second one is the volume correction. Ideal gas equation derived from van der Waals equation means two correction. First one pressure correction, second one volume correction. Now, pressure corrections. The pressure of the gas directly proportional to the force created by the bombardment of the molecules on the walls of container. The speed of a molecules moving towards the wall of the container is reduced by the attractive force exerted by neighbors. Hence, the measured of the pressure lower than the ideal pressure of gases. Van der Waals introduced correction term of the effect. You see the corrections. Molecular, that is center one diagram, molecular attraction balanced. The towards front means the input wall will be present. Intermolecular force between attractions. That means wall are the directly proportional to the square of the density of the gases. That means pressure dash directly proportional to density squared. So density equal to number of moles divided by volume. Rho value you got to apply the formula. B dash directly proportional to n squared divided by b squared. The directly proportional introduce the constant means which constant is p dash equal to a into n squared divided by v squared. That n is a is called proportionality constant. Therefore, p ideal equal to p plus an square divided by v square. Equation number 1. Next, second correction, volume corrections. Volume correction. Volume correction, that every individual molecule gas occupies. Every individual molecule means this is one molecule that occupied the value is the center of the nucleus. Occupy means that is what distance to r. That is occupy means that is the occupied volumes. This is called excluded volumes. Excluded volume. V van der Waals introduced correction factor V dash to this affected. Let the calculate the correction term for molecular sphere. This is for molecular sphere. Molecular speed of the two molecules means 4 by 3 pi 2r cube. Now, to give 8, 4 by 3 pi r cube equal to 8 Vm. That Vm is called volume of single molecules. Volume of single molecule. Exclude volume for single molecule 8 Vm divided by 2 equal to 4 Vm. So exclude molecule of for n molecule means n equal to n 4 Vm equal to Np. The B is called van der Waals constant. Is where equal to V dash equal to Np. Now V ideal equal to V minus Np. Equation number 2. Equation 1 and 2 apply for PV nRT. PV nRT. P means P in substitute for P plus an squared divided by b squared into b minus nb equal to n naught t. Equation number A and B is the van der Waals constant, varies from nature of the gases. Next, derivation of critical constant from van der Waals equation. What are the derived means? Critical volume equal to 3V. Critical pressure equal to A divided by 27 B squared. Critical temperature equal to 88 divided by 27 RB. These three equations only derived from van der Waals equations. So van der Waals equation for n molecules, that third equation you have to written P plus an square divided by V square into V minus NB equal to nRT. Equation number 1. From this first equation, n equal to 1 mole. N equal to 1 mole. If substituted n value 1 means that formula P plus A divided by V squared into V minus P equal to RT. That is equation number 2. Second equation you have to expand. First multiply with V. That means P into V. PV plus that V squared V cancel means A divided by V minus next multiply with minus P. PP minus AB by V squared minus RT come to the right side. So plus come into minus equal to 0. Equation number 3. Equation 3 multiply with V squared by P. Multiply with V squared P. Third equation multiply by V squared P. First time you have to multiply means P cancel. So V squared divided by V. PV plus A divided by V. That V cancel remaining minus PP AP divided by V square minus RT equal to 0. Now multiply. V square into V cube. PP cancel. PP cancel. V cube only present. plus v squared v cancel means AV divided by P plus PB cancel. So P V squared minus AB divided by P minus 40V squared divided by P equal to 0. Equation number 4. Rearrange the equations. Rearrange the equation power of V. Rearrange the equation power of V means first V cube, second V squared, next V, none of V. First V cube. V cube minus RT V squared divided by P plus P V squared minus plus A divided by P into P minus AB divided by P equal to 0. Equation number 5. Cubic equation of V. Get three solutions. Critical point of these three solutions: V equal to critical volume, critical pressure, critical temperature. That means V equal to critical volumes. So V minus Vc equal to 0. Next V minus Vc cube equal to 0. That means A minus P cube equal to 0. A minus P cube expand means A cube minus 3BA squared plus 3B squared A minus P cube. That A come V, B come Vc. You apply the formula. That means V cube minus 3 VC V squared plus 3 V squared V minus Vc cube equal to 0. Equation number 6. Calculated coefficient of P squared V from equation 5 and 6. That equation 5, equation 6, V cube cancel. So remaining only taken 3 VC V squared, 3 VC V squared equal to minus RT V squared divided by P plus P V squared. RT P plus P V squared coming outside. So V squared and V squared cancel, remaining minus minus cancel means 3VC RT divided by P plus P. Equation number 7. So critical volume, so critical temperature, critical pressure, critical volume, so critical temperature, critical pressure. Next coming third term, 3VC squared V. Here A divided by PV, PV cancel means remaining 3 Vc squared equal to A divided by P. So pressure, critical pressure means Pc. Equation number 8. Next third concept, Vc cube and AB divided by P. Vc cube AB divided by P. So pressure converted to critical pressure. Equation number 9. Equalated coefficient V squared V from 5th and 6th. So 7th equation, 8th equation, 9th equation we will get from 5th and 6th. Equation 9 divided by 8. Equation number 9, Vc cube divided by 3Vc squared, AB divided by Pc, A divided by Pc, Pc cancel, A cancel, Vc cube, Vc squared cancel, remaining Vc by 3 equal to B. So Vc equal to 3B. Critical constant equation, critical volume will be obtained. Equation number 10. Equation 10 substituted in equation 8. So write equation 8. 3Vc squared equal to A divided by Pc. So Pc is equal to A divided by 3Vc squared. So A divided by 3B squared equal to A divided by A divided by 3 into 9B squared. So A equal to 27B squared. So BC is equal to A divided by 27B squared. Equation number 11. Substitute the value VC and PC. Equation VC and PC value substituted in equation number 7. Equation 7, 3VC equal to P plus RTC divided by PC. 3 VC value 3P equal to P plus RTC A divided by 27B squared. So B coming inside means 9B minus P equal to RTC divided by A into 27B squared. So 8P equal to TCR divided by A 27B squared. So TC equal to 8AB divided by 27 RB squared. So BB cancel. TC equal to 8A divided by 27 RB. That is equation number 12. So derivation of critical constant from VC. VC value obtained also. VC equal to 3P derived. Next PC value also obtained. A divided by 27B squared. And TC also obtained 8A divided by 27 RP. That is exam 5 marks side very important. So side by side you have to watch the video and write down and practice too. Next topic, liquefaction of gases for important commercial operations such as LPG and rocket fuels. We require the liquid state liquefaction method by based on a Joule-Thomson effect. Lowering temperature when gas is made up of expand adiabatically from region of high pressure into region of low pressure is known as Joule-Thomson effect. This effect observed by sudden temperatures. There are different method used for liquefaction gases. First one, Linde method. Joule-Thomson effect used to get liquid air or any other gases. Next, cloud process. The gas allowed to perform mechanical work. In addition, Joule-Thomson effect, more cooling is produced. Third one, adiabatic process. Cooling produced by removing magnetic property, magnetic materials such as collodium sulfate. 1 mark said important. By this method, temperature is 10 power minus K to 0 Kelvin.